Welcome to HP Tuner's Ford Mod Motor Training Part 16. In this video, we're going to be taking a look at working with our cranking fuel and our warm-up enrichment fuel. We're going to have a lot to cover, so let's jump into our videos so we can check this out.
Okay, so let's get started. We're going to be taking a look at working with our cranking fuel and our warm-up fuel tables within our Ford PCM programming. Now, both of these have to be dialed in right so that we have the engine can fire up and then run at an appropriate lambda or target air fuel as it's coming up to operating temperature. Now, a few things about this that we need to note before we jump in and take a look at the tables. This is just going to be more of generic information across any kind of engine, but we need to know this in order to move into actually editing these tables properly. Now, when we're talking about an engine that's cold, so it's sat overnight, the ambient temperature might be 40, 50, 60 degrees, we'll find when we fire up the engine, the fuel isn't going to be able to atomize as well as it would on a warm engine. Now, in this case, as we're trying to spray the fuel into the engine, the fuel has a tendency to stick to the intake track and the intake valve. It actually is called a wall wetting effect when we have poor atomization for colder temperatures. Now, when we're in those situations, we need to deliver additional fuel above and beyond what we're finding from a normal warmed up engine condition so the engine runs properly. When we don't have proper atomization to the fuel and we're trying to deliver it into the engine, we're going to have a torque loss. The engine won't make as much torque, so it's going to be prone to try to idle lower because we have less idle torque to make the engine actually idle properly. So in order to get around a wall wetting effect and to get around having a torque loss or as much of a torque loss, trying to mitigate the torque loss, we're going to go in and try to richen up our fuel mixture both under cranking and when we're coming up to operating temperature. So after we fired off the engine's running for the first few minutes as it's transitioning from 40, 50, 60 degrees coolant temperature up to 170, 180, 190 degrees coolant temp. That's where we're going to consider the engine to be warmed up. In that transitional period, we have a warm-up enrichment that we're going to be usually going in and commanding a little bit richer fuel mixture so that, again, the engine warms up a bit quicker and it's going to be a bit more stable. Now, when you're on a stock engine or mild modifications, chances are you probably don't have to go in and edit your cranking fuel or your base fuel table, the base fuel table cold specifically. That's our warm-up enrichment style table. We usually don't need to change those values, but if you're modified, if you're running on E85 or have big camshafts or larger injectors installed, you're going to find that the engine isn't going to want to run smooth as it's coming up to operating temperature, or it might need more cranking fuel, and that's where we need to jump into these two tables that we have available to us within our Ford PCM programming so that we can make sure the engine's going to fire up and run properly to, again, overcome our wall wetting effect and to make sure when the engine's coming up to operating temperature that has adequate torque and that it will hold a smooth and stable idle. That's a really, really big part of the process here, making sure everything's going to be running properly so that we have the engine doing exactly what we're commanding. So let's go in. We're going to be opening up a file. I'm going to be looking at the file that we edited in a previous video, so that should go into our folder here. It's going to go to Open, and we're going to move into Base File 2. Let's click Open here, and then we're going to take a look at this file. So let's go here into Engine, and then let's move in here under our Fuel, and if we go here under General, we're going to find we have our very first table we're going to be discussing in this video here, Fuel Cranking versus ECT. Now, within this table here, you're going to find that the left-hand axis, this is going to be our engine coolant temperature. And then on the right axis, this is going to be our lambda, or what we're specifying we want the desired lambda to be at under cranking. Now, how this table works, it seems like it might be way too kind of a vague of a table. If you're used to working with cranking fuel tables for something like a GM, or if you're working with something like a standalone system and you know that you have a lot of options for cranking fuel, usually a lot of things you can adjust, this is going to simplify that and it's actually going to be much more ideal. Let's talk about how this actually works. So we know we have our airflow fuel modeling that's represented by the equation fuel mass is equal to air mass divided by target air fuel. So we would know what the air mass that's coming into the engine is under cranking conditions, either from the mass airflow sensor or from speed density calculations. So we'll have that covered. And then this table here represents what we want the desired lambda or air fuel to be at under cranking. So by specifying this at a richer or a lower lambda amount, that'll go in and it'll give us more injector pulse width under cranking to deliver more fuel. It's as simple as that. If we raise the number higher than 1.0 lambda or stoichiometric, that'll go in, reduce our injector pulse width and give us less fuel. Again, typically we don't need to go and change this, but that's going to be how the table works. Now, once we know what the air mass is going to be and we specified what we want the target lambda or air fuel to be at, then we know that it goes into the fuel mass side of things. Based on what we're programming for our injector data characterization information, it translates that fuel mass, or the requested fuel mass in the calculations, into an injector pulse width to deliver the fuel that we'd like into the engine. So the success of this table here really relies on our airflow model being right, and it relies on having our injector characterization data programmed for the injector sets that we're working with.
Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here. And you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.